Hello, I'm Keith Bamberger, and I am part of the Air Awareness Team of the North Carolina Division of Air Quality. The Division of Air Quality's responsibility is to make sure that North Carolina's air is clean for human health. If the air is unhealthy, we do everything we can to make sure that everybody knows both that the air is unhealthy and things that you can do to protect your own health. The Air Awareness Team's responsibility is to help people understand that individuals are both the cause and the solutions to our air quality problems, and the choices that you make every day can lead to cleaner air, better health, fewer greenhouse gases, and if you're lucky, you might actually save a little money, which is always a good thing. So today we're going to learn a little bit about air pollution, where it comes from, and some of those solutions. Welcome to one of the Department of Environmental Quality's science labs. And before we start doing experiments and demonstrations, I want to talk a little bit about science. Now first, science is a way of answering questions, investigating things, and it's all the knowledge that we've learned from science. So it's both a process and a set of knowledge or data. Second, scientists around the world are studying almost everything, but it's the way that they study it that makes it science. It's called the scientific method, and it involves asking questions, making predictions, using the data of everything that's gone before, and then testing those predictions. And then after you've made your discoveries, sharing that so other people can duplicate those experiments or findings. Third, scientific question is called a hypothesis. Now many people talk about a hypothesis as if it's an educated guess, but it's so much more than that, because it takes all the data that we know and combines that to answer the question. It makes a prediction, and it includes a way to test that prediction, test that data to see if you're right or wrong, and it gives you an opportunity to learn. Fourth, be safe. Because there are lots of different ways that you can, well, damage yourself, damage your tools. So you might be using fire. You might be using a knife. You might be using expensive technology. Be safe, protect the equipment, but most of all, protect yourself, because the most important part of any science demonstration, any science experiment, is your mind. And fifth, and last for now, everybody can do science. If you ask a question and work to find that answer, record what you find and how you got there, you're doing science. And science can be fun. Now we're going to do a couple science demonstrations here. So I'm going to start this part of the video with a simple sounding question. Is air? Now air, it's a lot of different things. I mean, we use it to blow up balloons, we use it to blow up volleyballs. Animals use it, and plants use it. We have lots of different tools to measure it. This is the thermometer. It measures the temperature of the air. We have barometers that measure the pressure. We have anemometers that measure the wind strength, and weather vanes that measure the wind direction. All these things measure the air. We even have tools which measure air pollution in the air and the parts of the air, like this. Well, my favorite definition of air is that it's a mixture of gases with a little bit of water, a little bit of solids, surrounds us all the time, and it keeps everything alive. Excuse me for interrupting myself, but I want to touch on what air is really quickly. Air is a mixture of gases with a little bit of water and a little bit of solids in it. But we at the Division of Air Quality, we think of it as molecules, the things that make up matter. For instance, 78% of the air is this molecule. This is nitrogen, triple bond. super strong. The most important part of air, most people would say, is oxygen, because we breathe it in. 21% of the air is oxygen. Now there's a little bit of a gas called argon, 0.9%. They don't make models of it, so I can't show you what it would look like, but it would be like a plastic bead. There's a little bit, I mean a very little bit, 0.04%, 400 parts per million of carbon dioxide. Got the carbon, 2 oxygens. Very important. I might say the most important thing in the air. And then there's another molecule which sometimes in the air, sometimes isn't. It's why people watch the weather to find out what it's doing. H2O, water. We watch the weather to find out whether or not it's going to rain or snow, or find out what the water vapor is doing, what the humidity is doing. It's what air is made out of. And it's important because it does keep everything alive. So sometimes, in addition to the oxygen, nitrogen, carbon dioxide, water vapor, and argon that's in the air, sometimes there are other things in the air, man-made things in the air, and we call them pollution. Now, pollution includes a lot of different things, but almost all of it comes from one thing: combustion or burning, the smoke that comes from burning. So I'm going to do a quick demonstration about combustion. Now, during this demonstration, I'm going to ask you to make a prediction, but I'm also going to advise you not to try this at home, because I'm going to take this, a plastic soda bottle, this, a fireplace match, a special modified cork, and a lighter. Now I am going to light this match on fire. I am going to put it inside that plastic bottle. And when I do this, I do it very carefully because, well, I don't want to set off the smoke detectors. I don't want to meet the local fire department this way. I don't want to break the Division of Air Quality's rules that say it's illegal in North Carolina to burn plastic. And I don't want to burn myself. Now, while I do this, I want you to make a prediction for me. I want you to predict what will happen to the flame once I put it into this bottle. Give you a second or two to think about that. You ready? Okay. Let's go. Got a good flame. I'm going to put it into the bottle. And as you can see, it is burning. What you can't feel is that as I do this, the bottle gets hot. It's also getting a little bit tighter. And now it's gone out. Now as you see, the smoke originally goes up, but then it falls back down. The reason smoke rises is because heat, warm air is less dense. So the smoke from that flame is raised up and it goes up, but then it cools and comes back down. And you may be seeing, as you try to look through this at my face, the bottle has gotten cloudy. Well, that cloudiness in the bottle is smoke. Now, smoke, of course, is it's a product of burning. So I've captured this smoke in the bottle. Now, this would be really unhealthy air. This is wood smoke. Different things when they burn create different types of smoke. The smoke from burning coal is much dirtier than smoke from burning wood, especially wood at low temperatures. Smoke from a wildfire is more harmful than smoke from a controlled burn. This is the AQI. It's a tool we use to talk about smoke. And regardless of the type of smoke, the color refers to the behavior you can do to protect your own health. So we have tools that measure air pollution. This uses a filter. As I shoot Each one of those dots is an hour of air pollution. We also have tools which tell us what's in the air immediately. Now this is an air quality sensor. We call it Casper because it looks like a ghost. On the phone, you can see numbers. That's measuring the amount of smoke that's in the air. I'm going to take the smoke that's been captured in this bottle and slowly blow it onto Casper. You should see the numbers change.
They're going up.
The machine is literally got a fan, so it's sucking that in. Uses lasers to tell what's in the air. Alright. So now, since I've taken the smoke away, the reading should go down. And you might have noticed that the dot changed from green to another color. We have an air quality index. Green is good air quality, yellow is moderate, orange means it's unhealthy for sensitive groups, red means it's unhealthy for everybody. You can go up to purple or maroon or even sometimes with forest fires black. And we have behaviors that you can use to protect your own health depending on what that color is. Orange, which is the worst we're going to have usually in North Carolina without a forest fire, means that people sensitive to air pollution should spend less time being active outdoors in the afternoon.
So when you ride the energy bike, you use your own energy to create electricity. Usually electricity comes from burning coal, which is a rock, burning natural gas, or nuclear power. All of those have their own set of environmental issues. But the combustion creates air pollution. So when you reduce the amount of electricity you use, it's better for the air. There's less greenhouse gases going into the air. It's also better for your health. And you might save some money. Because when you use less electricity, the power companies don't charge you enough. Or if you have solar panels, you get to save money. Same thing is true with transportation. When you drive more efficient cars or eliminate driving by carpooling or trip chaining or riding a bike or walking, again, it's better for the air and it's better for the environment. I wish you could have ridden the energy bike today, and hopefully in the future you'll be able to do that when I take it out to places like the Arboretum in Asheville or other events. But until that time, I hope that you enjoyed my presentation and have a good day.